last part, so I'm sure there'll be a curve on it. All right. Okay. Who is with us this morning? Let's see. Who do we have zooming in? Charles. Hey, Charles. Sorry it took us so long. The internet at school is spotty, so sorry about that. Okay. So all right, y'all, so y'all did take your quiz on Friday, and that hopefully went well. I know that some people may have missed it because of it being timed, but that's the only way that we can do it with this just being my first hour with Algebra 2. I'll miss to do it during that time slot, so you got to make sure you're waking up and logging in. Okay, Charles, are you still with us? I'm afraid I'm going to lose you because the internet is so bad.
Well, I can hear every 5 words.
Okay, good. Oh, this is great.
As long as I can see the screen.
Okay, you're good to go?
Yes, because I can see the notes being written.
Okay, good. Charles was in there one day and there was no voice. Like there's just nothing. And so at the end of the lesson, I could see him on the chat being like, I'm just winging it. I'm just writing down.
Yeah, I just watched TV on my phone as I was looking at my computer screen writing notes.
All right. What TV show do you like to watch?
Oh, I watched a couple.
Okay. I'm currently into Private Practice because I love Grey's Anatomy. Y'all? Oh, I love Grey's.
Oh. Oh, God. All the girls in the room just spoke up.
Yep. Mm-hmm. You don't even have to see us to know. We all love our Greys. Okay, y'all, we are, I think, on page 17. Y'all look and see if we're on page 17.
I can't watch that show.
You can't watch Greys?
Because of what happened.
Because of, oh, she hasn't seen. Okay. Okay. No, those people are my family. All right. Is that 17? 2-1, 17? Okay, cool. All right. So that's where we're at. We're on page 17 in your textbook. We're starting lesson 2. Okay. Hopefully we can get through this. It took us 10 minutes to even get going. So we'll see. But no big deal either way. All right. So first thing we're going to talk about is what we are even doing today. We are going to write equations in 2 variables to represent relationships between quantities. And then we are going to graph equations on the coordinate axis with labels and scales. Wait for it. I mean, just everything is going so slow. And I even restarted my computer this weekend.
Quick question. If
Go
the
ahead.
internet at school collapses, do I still need to do my work?
I'll make an announcement on the Canvas to say what you have to do if it collapses, okay? All right, so write equations in 2 variables and graph equations. Those are the main things that we're going to be doing, okay? Writing equations, graphing equations. It says, Roy recently won a trivia contest. The prize is a 5-day trip to New York City, including a round-trip airplane ticket and $3,000 in cash. The money will pay the cost of the hotel room, meals, entertainment, and incidentals. To prepare for his trip, Roy gathered this information. A hotel room in New York City costs $310 per night, and the trip includes staying 5 nights. A taxi between New York City and LaGuardia Airport will cost $45 each way. Roy must set aside the cash required to pay for the hotel room and for the taxi service to and from the airport. Once he has done this, Roy can begin to make plans to enjoy the city with the remaining prize money. Number 1, how much money will Roy have available to spend on performances, meals, and any other expenses that might arise after paying for the hotel and the taxis? Show your work. Okay, so what do we know? $310 per night. How many nights is he going to be going? 5 nights. So how do we figure out the total amount of money he's going to spend on the hotel? $310 times 5. All right. Y'all got a calculator? I mean, we could do this old school. Multiply. So is it 1550? Yes. All right. So that's how much they're going to spend on the hotel. That's the total for the hotel. He's going to take that out first. And then for the taxi, how much is the taxi going to be? $45 each way. So that's $45 twice. So multiply by 2. What's 45 times 2? 90. All right. So how much did he have to begin with? 3,000, right? And then what are we doing with the hotel cost and the taxi cost? You're subtracting it. So we're subtracting 1550 and we're subtracting 90. So how much money does he have left over? Minus 90. That's right, 1360. So that's the money that he gets to use to have to do his stuff. Okay, so 16. Oh, did they do your tip? Let me check your tip. I'm sure you're fine, but you're good. All right, so this is what he has for the remainder. What's number 2 say? Oh, it doesn't. At the bottom of the page, it says, during his trip to New York City, Roy plans to spend only his winnings from the contest. He wants to focus on 2 of his favorite pastimes, attending theater or musical performances and dining in restaurants. After surfing the web, Roy determines the following facts. On average, a ticket to a performance in New York City costs $100, and then he will spend on average $40 per meal. Okay, so that's what he's spending on meals and tickets. All right, next page. Roy wants to know how to purchase, Roy wants to know how the purchase of each ticket affects the available money. Fill in the table below, plot on the graph. Okay, so we're dealing with his leftover money. How much money does he have available if he buys 0 tickets? One at 1360. We're on page 18 of your textbook. Do what? You don't have your textbook? Okay. I didn't give you one at all? Here. My bad. Now you do. Let me write your name on it real quick. Caleb, C-A-L. There you go. Page 18. All right, so 1360 is what he's got. What tickets are we buying? Tickets to the musical performances. How much is each ticket going to be? Said it on the previous page. $100. Okay, so $100 per ticket. Okay, so if he buys 1 ticket, how much money will he have available? $14.60 or or 1260? Good, it's gonna go down, okay, because we're taking away $100 because we're going to one performance. If he goes to two performances, how much will he have left? 1160. Okay, three performances, 1060. What's next? If he goes to four performances, what's that going to be? 960. Five performances, 860. Now we jump from 5 to 8. What is it? Okay, 560. And the way you could do this, if you weren't sure, is you could say, you know, it's going to be $800 because 8 tickets is $100, $800. And then you could just subtract that from that original amount that he had left over, the 1360. And so, yes, Cole is right. It's going to be $560. Okay, because that's going to be $1,000. So if you subtract 1,000 from 1360, that's right. Good, David. What if we bought 13? $60. All right, then they want you to plot your points. So you've got the number of tickets, 0 tickets, 1360. So what are we counting by? Each tick mark is 100. So it'll be kind of close to the 14. 1 would be 1260. And again, like, I'm just getting these as close as I can. There's no way for me to be exact, especially on this big board. 2 would be 1160. 3 is 1060. 4 is 960. 5 is 860. 8 tickets is 550. 10 tickets is 360. And 13 is 60. All right, so it doesn't have to be just like the best thing you've ever done in your whole life, but just get it as close as you can. Just getting those on there. All right, what kind of pattern do you notice? Are we increasing? Are we decreasing? Decreasing. Randomly or at a constant rate? Well, what's happening for these? It's going down by 100 and then it skips. So, but you're skipping numbers of tickets too. Like this is 1 ticket down 100, 1 ticket down 100. Then we're saying an extra 3 tickets, extra 300. So I'm just going to say at $100 per ticket. So it's decreasing at $100 per ticket. Now it says number 4 down there. Explain how you determine values for 8, 10, and 13. You may have done things differently. I kind of showed mine here. So I would say I multiplied the number of tickets by $100 to get the cost spent on tickets, then subtracted from the original total. So my number 4 would say multiply ticket number by $100, then subtract from. Now, if you did yours differently, you would answer your number 4 based on how you did your number 4. Okay, number 5. Number 5 says write a function MT that represents the amount of money that Roy has left after purchasing T tickets. So, number 5, if we are going to write a function MT, basically that's replacing the Y. It's just the name of the function. Instead of just saying like, you know, Y equals, we're giving it a specific name. Like instead of me just saying boy and talking about David, like I say David, okay, not just boy. So that's all that is. It's just a name, okay? So M of T. So what function would represent what's going on right here? What are we doing mathematically? We start out with how much money? $13.60. That's how much money we start with. And then we're taking away money. How much money are we taking away? $100 per ticket. So you let the T represent ticket. And that would be our equation. $13.60 minus 100T. Okay? So if we looked at this in terms of a linear equation, I think that's what the next one is going to talk about. What would the 1360 represent? Is that your slope or is that your y-intercept? Well, remember the slope is the one that's going to be connected to the unknown. Okay? Well, that's going to be this one. Whereas the one that's just by itself, B, is going to be our 1360. So they have this written backwards is what it is. So they actually have it written as y equals B minus, well, plus negative mx. Okay, because our slope is negative because we're decreasing. So this is my y-intercept. Or my initial value. That's spelled wrong. It's all right. We're going with him. Okay. Let's see. Is Charles still with us? Yeah, cool. All right. And then this is my slope. Okay. So that's my slope. And so what is the rate? Minus 100. We're decreasing 100 per ticket. All right, so I think I probably just answered number 6. Number 6 says use mathematical terminology to explain what negative 100 and 1360 each represent in the function. So I did. So this is number 6. Okay, number 6 is here. 1360 is the y-intercept or your initial value, and 100 minus 100 is your slope or your rate. Okay. All right. So you should have answers for 2, 3, 4, 5, and 6. Anybody not have answers for those? Need me to repeat something? All right, cool. Well, let's switch and let's look at food. All right. Number 7 starts our food, which if I go to New York City, that's what I'm looking for. Do y'all, when y'all go to like different cities, do y'all try to do different restaurants or do y'all like end up eating the same thing you eat at home? Yeah. It's so good. I've only been in New York once, and it was when I was in high school, and we went with like my choir from church. We did like a little performance or something. It was like around 9/11, which that's how old I am. So we went and sang at the hole where the towers were. Anyway, so we were only there for like maybe 12 hours. So I don't really count that as even going. Really? Oh, that's so fun. That's cool. No, my parents were poor. Our vacations were to like Arkansas. So that's okay though. We had fun. There was a lot of us. I have 3 siblings, so we always had fun. All right. Roy wonders how his meal cost will affect his spending money. Write a function, dm, that represents the amount of money Roy has left after purchasing m meals. Okay, so the last equation that we wrote was mt, which was this. That represents the tickets, okay? Well, the difference with this is dm is going to represent the meals. Whoops. Okay, so how much money does he have left over to spend on fun stuff? $13.60. Okay, how much does each meal cost? Do you remember it was from that first page? $40 per meal. So we have a similar function, but this one's different because our rate has changed. Instead of spending $100 per ticket, we're spending $40 per meal, okay? Now, from this, they want us to graph, just like we did before. We could give ourselves a little table, just like we used before. This would be our meals. This would be our money. So if we bought 0 meals, how much money do we have? $13.60. If we buy 1 meal, then we're going to have $13.20, right? But like realistically, over 5 days, are you going to eat 1 meal? No, you're going to eat at least 5. So let's do 5. Okay, that would be 1 meal a day. So how do we know what to subtract right here? That's right. You need to plug that 5 in for M. What's 40 times 5? Not 200? Or am I making that up? Would that be 200? Y'all kill me. That's correct? Okay. So then 1360 minus 200 is what? 1160. Okay, well, let's say we have 2 meals each day. That gives us 10 meals. So then we come back over here. We plug in 10. So how much money would we spend on meals then? $400? So how much money would that leave us? $960. Okay, what if we splurged and had 4 meals a day? That would be 20 meals. Okay, breakfast, snack, everything. What's 40 times 20? What is it, 800? What's left if we spend $800 on meals? Is that 560? I suck at mental math, can you tell? Yep, okay, and I just don't trust myself. I don't want to mess up the problem. All right, so that gives us some places to put some meals, put some amount. So if we spend $0, then we are going to have, or if we spend 0 meals, $13.60. So you can see you have the same y-intercept that we had before. That's the amount of money that we're starting with, regardless. Then if we buy 1 meal, what's this counting by? That first tick mark doesn't count as 1, does it? We're counting by 5s. 5, 10, 15. So I'm not even going to put 1 there. That's going to be too confusing. I'm just going to jump to 5 and put 1160. So I've got this one. I didn't do that one. Then I've got 10, 960. Okay. Then we jump to 20. We still have $560 left. Okay. Let's look and see how much money we have if we bought 40 meals. What's 40 times 40? Would that be 1,600? So we can't get 40 meals. That's too much. Okay, 40 is too much. So let's try 35. So what's 40 times 35? That may be too much too. 1,400, so that's too many. So we'll say 30. It's going to be 1,200. So what is that going to leave us with? 160 bucks. So that would be 30 meals, be 160. Just like that. He's going to, yes. He's trying to figure out how he wants to spend it. Does he want to spend it on movie tickets or performances, or does he want to spend it on food? So that's what we're looking at to determine this. So he's obviously a planner because he's thinking this much about how he's going to spend his money. I just go and spend my money, and then I'm like, holy crap. Why do I owe the bank $5,000 from this trip? All right, so what kind of function is DM, this function? Is the function linear? Does it have a constant rate? Yes. So number 8, it's linear. Okay, and you can kind of see that on my graph. Graph is really kind of hard to see the linear function, but it is decreasing at a constant rate of change, and that is what number 9 wants to know. What is our constant rate of change? Minus $40 per what? Per meal. Y'all are killing me. Only being 5 people in here, and y'all are all quiet people. Yeah. Yeah. All right. So the math tip over to the side, read that. It says the rate of change of a function is the ratio of the amount of change in the dependent variable to the amount of change in the independent variable. So we usually write it as the change of y over the change of x. If you see those little fancy triangles, that's what that means, change of. So that goes with this little math tip right here. Or a lot of times you just see y2 minus y1 all over x2 minus x1. Okay, and so that's really the formula that you'll see a lot to represent the rate of change. Number 10 down there says, are all of the values for M on your graph valid in this situation, given that M represents the number of meals that Roy can buy? Explain. So would all of this be valid information and realistic for our situation? What they're saying is, like, how many meals is he realistically going to eat in 5 days' time? I mean, would you say 3 meals a day? So what's 3 times 5? So that's kind of realistic. Maybe he splurged and had 4, but even if he had 4 in 5 days, how many meals is that? 20. Okay, so he's probably not going to eat more than 20 meals. So anything that's on this side of the graph over here isn't really realistic. He's not going to eat 35 meals. I mean, it's just he doesn't have that much time, and he would throw up because he would be so full. Okay, so some of that data is not realistic. And that's what they're wanting us to realize. So let's check our understanding to make sure we get what's going on. It says, what do the x and y intercepts on the graph of item 7 represent? So here's item 7. What does this y-intercept right here represent? What does that represent, you guys? What's the 1360 represent? The money. How, the money when? That he has to spend, right? The y-intercept represents the 1360, which is the money available to spend. Okay, now we didn't do the x-intercept, but if we did, like if I drew my line from here down, what would that x-intercept represent? It represents the number of meals that uses all of his money. So if he gets that black dot, let's just say that's 37 meals. If he buys 37 meals, then he has no money left, zero money. Okay, so that's what represents. This up top represents the total amount of money he's got to spend. This represents how many meals are going to bankrupt him. When will he have $0? That tells you how many meals. Okay, number 12 says, if you know the coordinates of 2 points on the graph of the linear function, you can determine the function's rate of change. Okay, how do we find the rate of change? I just gave you the equation. So if you know 2 points, then yes, you can, and you would use that equation. That's number 12. So number 12 is a yes. If you know 2 ordered pairs, then you just plug it into that function. 13, what is the relationship between the rate of change of a linear function and the slope of the graph? What's their relationship? Rate of change and the slope. They're the same. They're the same thing. Okay, rate of change and the slope are the same thing. It says, the book says, the rate of change of a linear function is the same as the slope. So they just wrote it in a sentence. 14, using only your answers from items 12 and 13, explain how to write an equation of a line when you are given the coordinates of 2 points on a line. So if I give you 2 points, let me give you some real numbers. And tell you to write me an equation. Okay? What's the first thing that you're going to do? Find the slope. Okay? You're going to do that with y2 minus y1 all over x2 minus x1. That's the first thing you're going to do. Write this down. This is number 14. Number 14, the first thing you're going to do is find the slope. The second thing that you're going to do is use that's called point slope form. Do you remember point slope form? We'll practice it some more. But this would be the second thing that you're going to do. You plug in the y1, you plug in the slope, you plug in the x1, and then you simplify. And when you simplify, what should your equation end up looking like? This is the one thing you should have learned from Algebra 1 and remember for the rest of your life. Y equals mx plus b. That's what it's going to simplify down to give you. So the first thing you do is find the slope. Once you find the slope, you use point slope form. You plug all those things in, then you simplify, After you simplify, you should get y equals mx plus b. How come I cannot spell simplify? Simplify. Okay. That's how you would do that. Number 14, just one of the instructions. So that's how you would do that. I think that you get to write some equations in your homework tonight. You do. Okay, so your homework is on page 20, and you are doing 15 through 20. Give those your best effort. Try to work each and every one of them, at least attempt every single one of them. And then what do I need you to submit to me for today? Notes and homework, both. Okay, I've started taking points off if you don't do all of the homework and not do submitting the notes. So if you don't submit your notes and you don't finish your homework, you may get an 8 out of 10 or a 6 out of 10 or a 5 out of 10, depending on how much you do. Okay? Any questions? Any virtual questions? Okay, that's it then.